with my denominator. Now, before I walk away, I'm not putting it in radical form. Nothing tells me to do that. I just write it with positive exponents. So instead of x to the negative 4/3, my answer is 1 over x to the positive 4/3. Take its ticket, move it to the bottom. Now, you may have some simplification to do first, and you may not have common denominators. X to the 3/4, so 3/4, times x to the 1/2 over x to the 4/3. Now, by order of operations, this right here, it's not really part of PEMDAS, but order of operations says if we've got a rational bar, that's a grouping symbol. And that means do everything you can to simplify the top and the bottom separately, and then the last step is you'll let them interact and divide. So if you've got more than one like base up here, you need to combine them into one. And when you have a single x on top and a single x on the bottom, then you'll use your quotient rule and subtract. So first I got to clean this up on top. This is x to the 3/4 minus, oh, I'm sorry, this was supposed to be a negative 1/2. So 3/4 plus negative 1/2. And this, nothing to do with it yet, except just drag it along. Now, I want you to go either by pencil and paper or mentally, you need to handle those fractions. You need to know there's not a common denominator, so I need to change that to negative 2/4, and then add that to 3/4, and that'll give me a positive 1/4. Okay? If your eyes just crossed when I said that, got to practice the fractions. Woo. But I don't want you to hit a wall and get these problems wrong because of fractions. Okay? So even though I want you to be able to do that mentally, make sure if you're using the calculator, you use it correctly, because you want to be able to show me you know the rules, not that you know how to manipulate fractions. If you're going to do fractions in the calculator, just make sure you enter them in everyone individually in parentheses, because otherwise that division sign you use to make a fraction will confuse the order of operations in the calculator. So if I wanted to do that in the calculator, which I'm telling you is 1/4, because it's 3/4 plus negative 2/4 for a positive 1/4, in the calculator it would look like this. Parenthesis, 3 divided by 4, close the parenthesis, plus, parenthesis, negative 1 divided by 2, parenthesis. Now, when you push enter, you may get a decimal. Never give a decimal answer. So when I push enter, yes, I get a decimal. I need to change it back to a fraction, and remember that's math, enter, enter. Math, enter, enter. Positive 1/4. Okay? So, common denominators, just combine the numerators. Not common denominators, you need to make them have common denominators, or use your calculator as a backup. So this becomes x to the 1/4 over x to the 4/3. Now you use your quotient rule, x to the 1/4 minus 4/3. Okay. Again, 1/4 in parentheses minus 4/3 in parentheses, or a common denominator of 12, making this 3/12 minus 16/12. Okay. However you get there, 1/4 minus 4/3 is x to the negative 13/12. You're not told to write this in radical form. There's nothing in the directions that tell you to do that, but you can't walk away while there's a negative exponent. So it's 1 over x to the positive 13/12. Okay. 3x to the 1/5 raised to the 4th power over x to the 3/10. Again, like this one, you've got to clean up the top and the bottom separately, and then your final thing is the quotient rule. And this one up here, product rule said add the exponents. Here we've got power rule. And this power rule says that 4 belongs to both the 3 and the x to the 1/5. Numbers, we just power. 3 to the 4th power, 81. Exponents, how do we power that? What do we do the exponents? We've got x to a power raised to another power. That's the product rule. Here we were multiplying like bases, add the exponents. Here we're raising a power to another power. Sorry? Multiply. Right. So this is x to the 1/5 times 4. Or you can write it as 4 over 1. If one of your exponents is an integer, write it as over 1. Now, do you need common denominators when you multiply? No. Add and subtract, you do. Multiply and divide, no. Okay. So multiplying, you just multiply straight across. You can cross cancel, reduce the lowest terms. Okay. That was a fraction, that's not, so we'll write that as 4 over 1, so it looks like a fraction. Now we just multiply straight across. So this becomes 81. X to the 1/5 raised to the 4th power is 1/5 times 4. Power rule. Same rule you already know for integers, but now you're just doing fraction multiplication instead of integer multiplication. 1/5 times 4 is 4 over 5. No common denominator needed. X to the 4/5 over x to the 3/10. And now 81 x to the 4/5 minus 3/10. Like base, now we can single x on top, single x on the bottom, released all the parentheses with the power rule, now we can subtract. This is 8/10 minus 3/10, which is 81x to the 5/10. Common denominator, now we're subtracting, we have to have a common denominator. 8/10 minus 3/10, 5/10, which of course reduces to x to the 1/2. Don't be tempted to turn that into square root of x. There's nothing in the directions that says put it in radical notation. Now if you did turn it into radical notation, it would be 81 square root of x, not square root of 81x. Remember, base matters, that 1/2 only belongs to the x, not to the 81. Okay. So this would not become a 9 square root of x or anything like that. No. This is the answer. You don't have to put it in radical notation. If you did, it would be this. Base matters with fractional exponents just like with integer ones. It only is the base is the only thing the exponent is touching, unless there are parentheses. Okay. Power ahead to get the other rules. Are we okay with this idea? Ready to practice it? Okay. So that's the second rule. Again, not even using radicals on this one, just using properties of exponents. Okay. Now we're going to use rational, and I'm going to abbreviate that. Use rational exponents. Okay. To simplify radicals. Okay? So that means we're given a radical, and we need to simplify it. Okay? Well, we can't simplify that radical. If the exponent is smaller than the index, because the index tells us how many groups we need to make. Don't be confused. This is not the same thing as this. If I had x to the 12th, 4th root of x to the 12th, could I simplify that?
Yes.
Yeah. Because if I break that up, that's the 4th root of x to the something 4th. I can make those match. What would this be?
3.
Which means it would release to be x cubed. No problem. 4th root of x to the 12th is x cubed. But the 12th root of x to the 4th can't do it. Okay? Here I could make 4 groups out of 12. I could divide 12 divided by 4, make 4 groups of 3. Here, I can't make 12 groups out of 4. Okay? So before I'd walk away. Here, though, the directions tell me use your rational exponents. I can't simplify this, but sometimes when you change it to the other form, you can simplify. So I've got my 3 elements. I've got the radicand and an exponent and an index, and I'm going to change it to base, numerator, denominator. Base, numerator, denominator. Well, that is x to the 1/3, reduce the lowest terms. And now I put it back into radical, because I am simplifying radicals. So if I'm simplifying radicals, I want my answer to be in radical form. I just had to change it to rational exponents so I could simplify it, then I put it back where I want it. I put it back to radical form. So this is, yeah, this simplifies to this. But I had to use rational exponents to get there. I couldn't use the rules from x.1 to get there because my exponent was smaller than my, so this ended up changing my index when you use rational exponents. Because when you reduce that fraction, that's going to change your index. And this is true whether you have one element underneath or 2. Let's say we had x cubed, y cubed. Okay. And there's more complex ones than this, but this has the same exponent here to the 15th. By our product rule, we can write this as the 15th root of x cubed times the 15th root of y cubed. Now we can use our rational exponents and make this x to the 3/15 times y to the 3/15. 3 is smaller than 15, so I can't simplify it by our old rules, but when I write it like this, I get x to the 1/5 times y to the 1/5. If my numerator denominator can be reduced, if my exponent index create a fraction that can be reduced, then by writing it in fraction form, exponential fraction form, I can go ahead and reduce that fraction, because here I can't interact my index and my exponent. But when I write it in this form, my index and exponent can interact because they become one fraction. And so if that fraction can be reduced, now I put it back in radical notation, 5th root of x times the 5th root of y, because that's x to the 1/5, okay, y to the 1/5. And because they have the same index, my product rule says I can put them under one house with the same index of 5, and it's x1y, or xy. Now, so using this third rule here is using rational exponents to simplify radicals. So we take radicals that by our rules in 11.1 we can't simplify, so before we would have walked away. But now we know how to use rational exponents. Now, don't do this unless I tell you to. When you do problems on the test from 11.1, use those methods. Okay? Don't use rational exponents unless you're told to on this test. Okay? You often have a lot of choices. I want to keep those choices simple. Your directions that I give you mean something. Read them carefully. And if you're confused by what I'm asking for, then ask me when we do the test. Okay? So if it says use rational exponents, you go, oh, yep, can't do anything like that like I learned in 11.1. But if I convert it, because I can turn that exponent index into a fraction that can be reduced, and then I put it back as a radical, and it's still a radical that has been simplified in a way I couldn't do before. Okay? Whether there's one element or two. There's also a thing with numbers. I want to go ahead and show this last rule. So it's one less example in the class, but it's not one that you're going to see on the test. So it should be fine. So, all right. So the fourth rule is similar to this. We're going to use rational exponents again. Again, we're going to use these rational exponents because we're going to have some problems now that we can't use the rules we learned earlier. Okay? Here we couldn't use the rule we learned earlier because our exponent is smaller than our index. Here, we can't use the rules we learned earlier because we're going to be using rational exponents to write a single radical expression. So here you're given a single radical and you just want to put it in simpler terms, and you couldn't do it by the rules we learned earlier because the index is bigger than the exponent. Here, we're going to have two or more radical expressions, and we're not going to be able to simplify them because it's going to violate our product rule that we learned earlier. So here's a problem that we cannot do by our earlier product rule. So we're like, well, hey, the directions tell me maybe I can do it now, but with this different set of rules. So 3 cube root of x times the square root of x. Okay. So think back to our product rule from the first half of this unit, and by the product rule, can we put these under one house? Why not? Right, because the indices are different. Okay? Our product rule that we used before says, yeah, combine them under one house, multiply x times x under one house, and you keep the same index. Oh, that's not the same index. Okay? Okay, so we can't use that product rule. But the directions will give us a clue. Use rational exponents. Okay, so we'll rewrite it in a way that means the same thing, but the rules are inverse rules, so we will be able to simplify once we convert it to rational exponents. So cube root of x as a rational exponent can be written as, in fact, let me go to be real explicit here. This is cube root of x to the 1. We can write, even though we don't have to, we can write it in. And this is square root of x to the 1. Sometimes it'll help you see the fraction that you're writing. Okay? We don't need that 2 there or those 1s, but that becomes, yes, x to the 1/3 times x to the 1/2. Now, we can do that because we've got like bases. This product rule of radicals requires like indices. The product rule of exponents requires like bases. We have that. Okay? So that becomes x to the 1/3 plus 1/2, which is x to the 5/6, 3/6 plus 2/6, 2/6 plus 3/6, 5/6. And we want to write it, the directions say, as a single radical expression. So the directions tell you, don't leave it like that. We used rational exponents to simplify, but we can't walk away until we have a radical expression. So this is x to the index is 6. And do I put the 5 on the inside or outside?
Inside.
Yeah. Nothing to simplify, so much cleaner to write it on the inside. Okay. So one other quick variation of that, x, the 8th root of x divided by the 9th root of x. Can we use our quotient rule? Can we put these under one house? No, because the indices are different. If we put it under one house by our quotient rule of radicals, what index would we use? Okay? So we can't use the earlier rule we knew because the index is different. But we're given a clue in the directions. Rewrite it with rational exponents, x to the 1/8 over x to the 1/9. Now we have like bases, and we can use our exponent rules of x to the 1/8 minus 1/9. Of course, it's adding or subtracting, so we need common denominators. 72 would be the common denominator. So it would be 9 72s over minus 8 72s. So that's x to the 1 over 72. Okay. So common denominators, do your addition or, in this case, subtraction. And now, but we need to write it as a single radical expression, so we can't leave it like that. That becomes, base becomes radicand, index is 72. That's an ugly number, but it's true. And 1 we don't have to write. Okay.
Is there anyone where they don't have any like these?
Well, not that I'm going to give you. There is a variation on that. You can see, like I said, you'll see more in like the study guide and the exercises. But I want to keep just this down to the simple rules. Yes, there are variations, but what I just did here is exactly what you'll see on the test. So what you'll see on the practice exam, you'll see in the homework, and exactly what you'll see on the test. Yeah. And it's these basic rules that you're going to need moving into college algebra. We can get a lot fancier, but this is the basic understanding and manipulation of vocabulary that you need moving forward. Okay, I'll be down in the lab in 10 minutes, and you'll see the homework for this. Finish up your equations in 11.6. You'll see the homework for 11.2 post within the, by 12:15 at the latest. Not yet. They'll post tomorrow. They'll post under exam practice in my math lab. Sure. A negative on the outside? Right.
I was good over here.
Oh, okay. So there was no negative in the problem.
Right, no,
Right. Okay, yes. And because this is an equation, that's not really, I understand what you're asking, but it wouldn't apply in this case because of the equation. Because if there were a negative out here, we could just divide away the negative on both sides, and then we'd be good to go. But yes, if you were just given this and told to simplify, and there's nothing to simplify there, but this is real though, because the negative's on the outside, that's okay. That means if you could, whatever is in here that you could simplify would be negative.
Okay, because you had it.
Right. So if you just had that, you'd say, hey, I want the principal or positive square root. And if you put a negative on the outside, you're saying, I want the negative square root. But you have to say it explicitly on the outside. And if the negative on the inside, you say non-real. Well, it wouldn't be null because we're just talking about expressions. Null is something for equations. It would just be non-real, can't do anything. Yeah. Now that's an equation form, that's not really an issue because we would just divide it away. But if it was that, we have to say, oh, that is an issue because there's no way this can be negative. But if it were there, we can divide away and be okay.
Also, those 4 rules,
Uh-huh.
what were they? That was, I just don't know.
Sure. If you look on your practice test, they're all right here. Okay, so I went over them in that order in the notes, and I'm going to scan and post those notes as well, so you can look back over them. So starting here with number 22, here's the first one. And then,
No,
here's the
sorry,
second
I'm
one.
already covered.
This one is just, so this one is, this is in rational exponents, write it with radical notation. And then simplify. This one is no radical notation at all. Here's an exponent, just use your exponent rules. Properties of exponents.
I read that.
Yeah, okay. And these are the last two where we can't simplify them as is, change them to rational exponents, simplify, put them back in radical. Those are the four. Yeah, you'll see it exactly like this on the practice and in the exam itself. Those four directions. You got a copy of the practice test?
Yes, ma'am. Thanks. Lots to take in.
Yes, it is. It's a lot of little rules, yeah.
I tried to keep up, like, I just don't understand, like, by the time